Hi, 8th grade. Welcome to lesson 6-7, Understand Similar Figures. By the end of the lesson, I want you to be able to say, I can use a sequence of transformations, including dilations, to show that figures are similar. Let's solve and discuss it. Andrew draws the two figures shown on the coordinate plane. How are the two figures alike? How are they different? And how do you know? Okay, so let's find similarities. This is so big. Similarities, and differences. Looking for participation. Hopefully you said that they're both triangles. And even more specific, they're both right triangles. They both have the points A, B, and C. But the second triangle is A prime, B prime, C prime. So we know it came from ABC. The difference is one is smaller, but it looks to be in proportion. So that tells me that there's been a dilation, what we learned last lesson. Focus on math practices. How can you use the coordinates of the vertices of the triangles to identify the transformation that maps ABC onto A prime, B prime, C prime? Well, let's write down what the coordinates are. A, B, C. A is at 1, 2, 3, 4, 5, 6, negative 8, 6. B is at negative 8, 2. C is at 4, 2. And then we'll find A prime, B prime, C prime. A prime is at negative 4, 2. Oh no, negative 4, 3, my bad. That didn't make sense. Negative 4, 3. B is at negative 4, 0. C is at, it's just here. B prime is at negative 4, 1. And C is at 2, 1. So, can we see a pattern? How do we get from the x and y values of A, B, C to the x and y values of A prime, B prime, C prime? A lot of you might say divide by 2. Remember, whenever we're doing a dilation, we're always multiplying. So dividing by 2 is the same thing as multiplying by 1/2. So it's a dilation. More specifically, is it an enlargement or reduction? Reduction. Okay, example number 1. Understand similarity. Albert graphed trapezoid ABCD and trapezoid GHJK. How can he tell whether the parallelograms are similar? Two-dimensional figures are similar. This is the symbol for similar. If you can map one figure onto the other by a sequence of rotations, reflections, translations, and dilations. So this is very close to congruent. Remember, congruent was like that. An equal sign with a squiggly on the top. Now, that was only because it was the same size, same shape. Now, we get rid of the equal sign, and it's just the squiggly on top, meaning it's just the same shape. We've changed the size. We've done a dilation as well. So determine whether there's a sequence of transformations, including a dilation, that maps ABCD onto GHJK. The trapezoids have opposite orientations, so the sequence must include a reflection. Reflect ABCD across the x-axis. So we do that, we get A prime, B prime, C prime, D prime. We know we need to make it smaller. So the sequence of reflection across the x-axis followed by a dilation of a scale factor of 1/2. There's when we made it smaller, our reduction. Centered at the origin, maps trapezoid ABCD to trapezoid GHJK. So ABCD is similar to GHJK. Similar figures have the same shape and congruent angles. The corresponding side lengths are in proportion. Try it. Is ABC similar to A prime, B prime, C prime? But we need to see if their side lengths are in proportion. Well, from A to B, it's 27. And from, that's not right. A to B prime, I meant. And then from A to B, it's 12. Looking at the other side, C prime to B prime is 27. And B prime, or B to C, is 12. We check to see if those are in proportion to each other. Does 27 over 12 equal 27 over 12? Yep, they are similar. What sequence of transformations shows that ABC is similar to A prime, B prime, C prime? Well, it would be a reflection over point B. So you'd flip, we'd take ABC, and we'd flip it over so that it would look like this. And now we need to make it bigger. And guess what? This is our scale factor. So then dilate, enlarge by a scale factor of 27 over 12. All right, example number 2. Complete a similarity transformation. Quadrilateral JKLM has coordinates. J is at 2, -1. So here's 2, -1. K is at 1, -2. L is at 1, -3. And M is at 3, -2. Graph J double prime, K double prime, L double prime, M double prime. Since we have those double primes, we know that 2 transformations are happening. The image of JKLM by a dilation with a center of 0, 0 and a scale factor of 3, and then a reflection across the y-axis. Well, first we'll do the scale factor of 3, and they did it for us. Notice that every x and y value has been multiplied by 3, and now we have J prime, M prime, L prime, K prime. Next we reflect over the y-axis, so we're flipping it over the y-axis. K prime was 3 away from the y-axis, so K double prime is going to be 3 away. Same with L prime and L double prime. J prime is 6 away, so J double prime is going to be 6 away. And same thing with M. Identify similar figures. Is ABCD similar to EFGH? Explain. Well, they look to be the same size, or they look to be the same shape, just a different size. We just have to make sure that there's a sequence of transformations that maps one onto the other. So compare the corresponding coordinates. So looking at the coordinates, we see that if we just multiply everything by -1/2, that tells me there's going to be a rotation of 180 degrees. Remember, because everything changes their sign. And then a dilation of a scale factor of 1/2. Graph the image of JKL after a reflection across the line x equals 1, followed by a dilation with a scale factor of 1/2, and the center of dilation at point J. Okay, so first we're going to reflect over the line x equals 1. Remember, that's where it crosses the x-axis at 1. So JKL, J is 3 away, so we're going to go 3 away. This is going to be, or that was L. This is going to be L prime. K is 1, 2 away from that L, so that's K prime. And J is 3 away, so we're going to go 3 away. Here's J prime. So now we have L prime, K prime, and J prime. Now, everything up until now, we've had a center of dilation at 0, 0. When it's 0, 0, that's why we can do the easy multiplication. But now we are going to do with a dilation point at J. So you start at J, and however far away the other points are, you decrease that by a half. So K is up 1, 2, 3, 4, and over 2. So the slope to K is 4, 2. But if we wanted to decrease that by half, divide both by 2. That would give us 2 over 1. So instead of up 4 over 2, we're going to go up 2 over 1, and this is going to be our K double prime. Now J is 0 points away. Why does that always happen? J is 0 points away from itself, so J double prime is the same as J prime. And now L is 1, 2, 3, 4, 5 units up. So we're just going to do half of 5. 5 divided by 2 is 2.5. So I'm going to go up 2.5 units, and there is my L double prime. So there's my new triangle after it's been reflected and dilated. Since we reflected and dilated, they are similar. So JKL is similar to J double prime, K double prime, L double prime. Is JKL similar to PQR? What we have to see, we want J to line up onto P, Q to line, or K to line up on Q, and R to line up on L. So let's see if we can't look at the coordinates and make sense of them. So J is at the coordinates -2, -4. K is at -4, 0. And L is at -2, 1. And then, erase this, P, Q, and R. P is at -4, 2. Q, oops. Oh no, that was right. Q is at 1, 2, 3, 4, 6. And R is at 1, 2, 3, 4, 5, 6, 2. Okay, so if I look at the points J and P, I can see something specific happening. The X and Y values are switching, so that tells me it's either a rotation of 90 degrees or 270. Looking at the figures, I can tell it's 270, so we're going to rotate it 270 degrees, and then I look at the lengths and see what my dilation factor is. L to J is 1, 2, 3, 4, 5, whereas P to R is 10. How would we go from 5 to 10? We would dilate by 2. But it's not from the origin, because you can tell that K times 2, the values of K times 2 is not 4 and 6. It's not dilating by the origin, it's dilating around the point J. Because J doesn't change when it turns into P after the rotation. Those stay the same. The rest of them will dilate by 2. Okay, 8th grade, let's say it. Oops. I can use a sequence of transformations, including dilations, to show that figures are similar. Have a great day.